In this video, we start applying modifiers and start combining objects. We also test Boolean subtraction. Let's get started. This is the animation we're aiming to achieve in this section of the course. The plan will roll open and the house will begin to reveal itself. You can make a storyboard to help with the timing and sequence, or just use this reference video. You'll find it in the resource folder. Also here, I've created a list of each object with a description of the property we keyframe, with the frame number and second included. These start as placeholder values and changed as I worked through the animation, adjusting the timings. The list should help you understand what steps to take to complete the animation. Feel free to adjust the sequence and flow. So now is a good time to save a copy of your work. Use Save As, and that way if you need to start over at any point, that file will still be available. We'll be using Boolean modifiers to subtract from objects, making them appear and disappear. In order to have this work correctly, there are a number of steps required. These include applying modifiers, removing parent-child relationships, and finally combining objects together. Also, we need to make sure there are no extra vertices, edges, or faces within the objects, as this can lead to the Boolean failing or getting glitchy results. Let's start by coming back to the Layout tab, where we have more viewport real estate. Drag select the trees. Press M and add this into the tree collection. In the outliner, we can switch off the tree collection for the moment. Then let's switch on the ground floor wall, the first floor wall, and the ceiling collections. The first object we can select is the ceiling object. In the modifiers tab, we can see this has a Boolean modifier that's subtracting the hole for the stairs. We need to make that hole permanent, so press Ctrl+A and apply the modifier. The wall objects don't have any modifiers, but select them and make sure. So select everything. Press Ctrl+J and join these into one object. Press F2 and rename this new object Walls. That makes two empty collections in the outliner, so select and delete these. We can rename the remaining collections Animation. Now we can test the Boolean object on this wall and make sure there are no issues before moving on. So press Shift+S and put the cursor to World Origin. Press Shift+A and from Mesh add a cube. Let's come into a front view. We can move the cube up to sit on the grid floor, so press GZ, input 1000 and enter. In the Object Properties tab, we can come down and expand the viewport display. From Display As, change this to Wire. That way we can see the subtraction happen. Let's tab into Edit mode. Press Z and switch to Wireframe Shading. Drag select the top vertices. Press G, Z and drag these up above the wall. We can switch back to Solid Shading. Also, come back to Object Mode. Let's come into a top orthographic view now. Press G and drag this to about center of the walls. Press S, Shift Z to exclude the Z axis from scaling and increase this to cover the entire object. Let's press GZ and drag this up above the walls first. Select the walls and in the modifiers tab we can add a Boolean modifier. Use the picker and select our cube object. Now if we select the cube, press GZ and drag this down. The house does start to disappear, but it's very glitchy. We can right click. The default Boolean settings work best on manifold or watertight meshes, closed volumes and not overlapping. Our walls are not manifold. To get around that, we can expand the solver options. With Exact Solver enabled, we can check on self-intersection. This solves the problem where geometry is overlapping. It's a slower solve, but we don't get glitchy results. So now, if we select the cube and drag this down over the walls, we should get a smooth subtraction without issue. So that's the test complete, and we'll continue to combine the remaining objects in the next video. In this video, we continue preparing the objects for animation. Let's get started. To begin, we can switch off the animation collection. Next, switch on the environment collection. If we select the grass object, in the modifiers tab, we can switch off the grass modifier. Having this left on would slow the viewport down. In the geometry nodes tab, the density value can also be reduced to maybe 10 from 100 here. That will help free up the viewport response time if you do want that grass enabled. These can slow everything down and make the computer feel sluggish. Let's switch back to the layout tab next. The external wall will be a separate object. Press F2 and rename this external wall. Now press M and move this into the animation collection. This base object will combine with the floor objects, so let's press H to hide this for the moment. Press A and select the remaining environment objects. These cannot be combined as they have particles attached, but we can press M and move these into the animation collection. Next, we can switch on both the FF and GF floor collections. All the ground floors have a solidify modifier, so select all of these. Then press Ctrl+J and combine them. Apply the modifier now. Let's press Alt+H and unhide the base. Select this as we also need to apply the solidify modifier. Let's Shift select the step, then the ground floor floors. Press Ctrl+J and join these into one. Press F2 and rename these GF_floors. For the FF floors, let's drag select all of these. Make sure one is active. Press Ctrl+J and join these into one. Press F2 and rename these FF floors. These will reveal at different times, so will remain separate objects. Press A and select them all. Press M and move these into the animation collection. Then in the outliner we can select both these empty collections and delete them. Next, we can switch on the Archimesh collection. We can start with the roof. The first thing I want to do is change the color of the roof tiles, so switch into the shading tab. Here, I'm going to make this a darker color to represent roof slates. Then we can hover on the color swatch and press Ctrl+C to copy the values. We can switch back to the layout tab now. In the material tab, open viewport display. Here, press Ctrl+V and paste in those color values and update the viewport. Let's open the modifiers tab. We can press Ctrl+A and apply the solidify modifier. Then we can X off the subdivision surface modifier. This can be added back later if necessary. Then apply both array modifiers. The second section of roof we can apply the modifier. Then Shift select both these objects. Press Ctrl+J and join into one. These will be a separate object. Press F2 and rename roof. Press M and move to the animation collection. Next we have the stairs. Apply the mirror modifier now. Press M and move to the animation collection. We can select this object we used to subtract the hole for the stairs. Press X and delete this. The railing objects will move into position, so the first thing we can do is select all three. Press Ctrl+A and apply all transforms. That way, if they are moved from position, inputting 0 in the location field will move them back to this location. We'll use empty objects to control these during animation, so each will need to be parented to an empty. I can cover the first, then you can get the remaining two done before the next video. Let's start with this one here. Press Shift+S and put the cursor to world origin. Press Shift+A and down here in empty, let's add a plane axis. Press F2 and rename this empty _front_balcony_rail. Now we can parent it, so select the rail. Shift select the empty. Press Ctrl+P and parent object keep transform. So now moving the empty object will move the rail, and we'll be adding keyframes to control this object's movements. Now we need to repeat that for the remaining two. Add two more empties. Rename them and parent the respective railings. Then move all these objects into the animation collection. We can continue in the next video. In this video, we continue preparing the objects for animation. Let's get started. Hopefully you have set up the tree empties and they're controlling the tree railings. So if each one is moved out of position, it will be just a matter of inputting 0 into the location transform. We can drag select all these objects now. 6 objects should be the total here. Press M and move these into the animation collection. We can then select and delete the Archimesh collection. Finally, we have the door and window collections to prepare. Let's start with the first floor doors and window collections, so switch these on. I'll cover the process with these 2 collections and then you can finish the ground floor collections before the next video. Let's zoom into the door handles. These have subdivision surface modifiers and will need to be applied. The easiest way is to combine all the handles first, then apply just one modifier. So let's come to the select menu and select linked. Here we can select material. That should select all the objects using the same material. So press Ctrl+J and combine these. Now in the modifiers tab, press Ctrl+A and apply this subdivision surface modifier. The next object with a modifier is the window sill, and this has a bevel modifier. So let's come back and select linked by material again and select all the window objects. Press Ctrl+J and combine these. Now apply the modifier. Next, we can drag select all the objects. Press Alt+P and clear any parent constraints and keep transformations. We won't need the empty objects, so from the select menu, let's select by type and choose empty. Press X and delete these. We also want to delete these subtraction objects, so again, from the menu, we can select linked by material. Press X and delete these. Now we are ready to combine all the objects that remain. So drag select what is left. Make sure one object is active. Press Ctrl+J and join these into one. Press F2 and rename these doors_windows. Let's tab into edit mode and select it all. Press M and merge by distance and remove any overlapping vertices. We can tab back now. Let's press M and move this into the animation collection. Then we can select and delete the empty window and door collections. Next, we can switch on the ground floor door and window collections. This will be the same process as the previous example. First combine the door handles and apply the subdivision surface modifier. Then clear any parent relationships and finally combine. So try work through the process and complete this before the next lecture. In this video, we continue to combine the remaining objects. We also check the face orientation and merge overlapping vertices. Let's get started. To begin, we can switch back on the animation collection in the outliner and also expand it. All the objects we need for the animation will be in this collection, apart from the tree and stones and grass objects. Let's select the 2 window and door objects in the scene. Press tab into edit mode and select them all. Press M and we can merge by distance. It's important not to have any overlapping vertices because this may affect the Boolean modifier. Let's tab back to object mode. Press H and hide these. The roof will be its own object, so tab in here and select it all. Press M and merge by distance. We can tab back now and press H to hide this also. Next, we can select the walls. Let's tab in here and merge any overlapping vertices. We can tab back now. We can hide this also. Shift select the top and bottom floors and tab into edit mode. Select them all. Press M and merge by distance. We can tab back and hide these also. Next, we can check the stairs, so tab in and merge any overlapping vertices. We can tab back now. Press H and hide this also. The railing objects we can just select and hide. Also, the 3 empty objects at world origin, let's select and hide these. Select the outer wall and tab in here. We can check this for overlapping vertices now. That's it, so tab back. Press Alt plus H and bring the hidden objects back. Press Q and check the face orientation. Some window panes may show red, so select them and tab in here. Select any red faces and recalculate to reverse them. We can tab back and switch off this overlay. Let's select this cube object we added earlier and press H to hide. We can press A and select everything else. Press Ctrl plus A and we can apply all transforms. That way, if you accidentally move an object out of position, you can easily zero out the location and put it back. In this video, we enable the Images as Planes add-on and import the plan texture. Let's get started. For this video, I'll be using wood plank textures for the tabletop. This will be an outdoor table, so download a texture set for that type of material. I already have one downloaded and ready to go. We'll also be using a plan texture for the plan that rolls open. I have provided a plan texture in the resource folder, so download that and have it ready. Let's press Z and switch to Material Preview. In the outliner, we can select the animation collection. That way, when we add the planes to the scene, we can be sure they get added to this collection. So press Shift plus S and put the cursor to World Origin. We can press Shift plus A and from the Add menu in Mesh, add a plane. This will be the tabletop, so needs to sit underneath everything. Let's press numpad 1 and take a look at its position. Right now it's sitting above the ground. So first, press GZ and snap down to the bottom of the wall. This will make it sit at the same level as our grass and tile plane. This will cause Z fighting and flickering, so we need to move it down a little further. In the Z location, it's currently -200. We can update this to -202. In the pivot menu, let's change the pivot to medium point. Let's tab into edit mode and select it all. Press S, X, input 60 and enter. S, Y, input 45 and enter. While we are in here, let's press U and unwrap this to update the UVs. Now we can switch into the shading tab. We can create a new material. Rename this tabletop. I can speed up adding in the plank textures. I've left the default scale of 1 on the mapping node. I did rotate the textures 90 degrees using the Z rotation field here. Let's switch back to the layout tab. Next, we need a plane for the plan texture. For that, we can use an add-on that will automatically add and set up the texture. So first, press F4 and open Preferences. In the Add-ons tab, search Image as Planes. This Import Images Plane add-on here. Enable this and we can close Preferences. Then from the Add menu in Image, we now have this option, Add Image as Planes. Navigate to where you saved the asset folder and stored the image called Plan Texture. Select it and we can import this image as a plane. That creates a plane, then creates a material with the texture added. We need this scaled up so that the drawing matches the size of the house. That way it will look like the house extrudes from the plan. So let's press S and scale this up first and get it close to the size we need. Then press numpad 7 for a top view. This first needs to be rotated, so press R, Z, input 90 and enter. In the animation collection, let's hide all objects except walls and the plan texture object. That will make placement much easier. Then center this drawing up on the walls. Now start scaling it to match the outline. If you zoom into the 4 corners, you'll be able to get this exact. Just make sure it's close and the 4 edges match all around. That looks good now. Next, we can position this on the Z-axis just above the tabletop. So in the Z location, we can input -201 here. In the Modifiers tab, we can add a Subdivision Surface modifier. This will add extra geometry to help roll the plan. We can increase the levels to 2 and increase the geometry further. Then set the algorithm to simple and keep the integrity of the corners. Press Ctrl plus A and apply the scale before we add extra geometry. Finally, tab into Edit Mode and select it all. Right click and we can subdivide it. In the options box, increase this to 20. Now we can tab back. In the scene, press Alt plus H and bring back all the objects inside the animation collection. In this video, we use a curve modifier to roll and unroll the plan. Let's get started. Make sure the cursor is at world origin. Press Shift plus A and in Mesh, add a plane. Press F2 and rename this Roll Control. We can then tab into Edit Mode. Select the two vertices on the left. Press X and delete vertices. We are going to form this into a spiral shape using the screw tool the plan can follow. Select the two remaining vertices. Next, we can use search, so press F3 and search screw. This one here, edge screw. In the axis X, we can input 1, tab into the Y and Z and input 0 for both. That flattens this along the Y. Let's switch to wireframe so we can see this a little easier. We need this wide enough so it's not bunched up at center. In the Y center, we can input 2420. We can increase the resolution of this by increasing the steps to 32. Next, we can have this repeat several times, so in the turns, input 8. Next, we can switch to edge selection and Alt select this second edge. Make sure you select the correct edge here. This will be the shape we use to roll open the plan. Press Ctrl plus I to invert this selection. You should have this selection now. Press X and delete edges. Next, we need to orientate this correctly. So press R, Z, input 90 and enter. Then press RX, input 180 and enter. Then finally, scale down, so press S, input 0.15 and enter. Let's come into a front view now. Press G and drag this up above the ground for the moment. We'll be positioning it more accurately later. Select the end vertex. Press Ctrl and select the 8th one in. Press X and delete vertices. We want this extruding straight out so the plan starts out flat. Select this end vertex. Press EX and drag this away here. Next, we need to set the origin of this object, so select the inside vertex. Press Shift plus S and put the cursor to selected. We can tab back now and right click and set the origin to 3D cursor. Then right click and convert this to a curve. Let's switch back to Material Preview. In the outliner, we can select the plan texture. In the Modifiers tab, we can add a curve modifier. Then use the picker to select our Roll Control object. That will roll up the plan. The plan may overrun the curve, so let's Shift select both objects. Press the / key and isolate. So if we select the Roll Control object and press GX, drag this across here, the plan should roll open. We'll have to align the plan to the walls again. So let's press the / key and return to global. These are way over here. So in the outliner, hide all the objects except the walls, plan, and roll control. Select both the plan and control, then press numpad 7 for a top view, and move these so the plan aligns again. This time one corner will do as we know it's the right size to fit the plan. So now if we select the control and move this back and forth along the X-axis, the plan will roll out under the position of the house and into position. The plan is down too far on the Z-axis, so in the outliner, let's switch back on the table plane so we can see this. Select both the control and plan. Press GZ and drag this up so the plan sits above the table. Just make sure it's just above and not at the same level, and avoid any Z fighting. We can select the plan and right-click and shade smooth. In this video, we start setting up the Boolean modifier to reveal the building. Let's get started. The first thing we can do is press Alt plus H and unhide everything. We added this cube object previously to test the Boolean modifier. We can finish setting this up now. Let's press F2 and rename this wall underscore cutter. We'll use this to subtract the walls, doors and windows. Let's move this into a separate collection, so press M and we can create a new collection. Rename this cutter objects. In the outliner, we can press the period key and bring this into view. It's really important we uncheck this icon, exclude from render. That way, this cube object will not be included in the final render. Otherwise, you'd see a cube covering the entire building. Let's come into a front view now. Press GZ and drag this to the bottom of the wall. To make sure there is no Z fighting and the Boolean modifier is below the ground, press GZ input -1 and enter. We can apply the location, so if it accidentally gets moved out of position, we can simply zero out the location. So press Ctrl plus A and let's apply all transforms. Let's press GZ and drag this up above the walls. Next, press Shift plus D and right click. Press F2 and rename this door underscore win underscore cutter. We can tab into edit mode and select it all. Press S Shift Z and scale this in a little so we can tell the difference between the two. Just make sure it's still covering the doors and windows. Scale it down a little more along the Y-axis also. We can tab back now. Let's select the doors and windows top and bottom. In the modifiers tab, let's add a Boolean modifier. Use the picker and select the door win cutter object. Change the solver to fast here. I find with more complex objects like these windows and doors, exact subtracts very slowly. Press Ctrl plus L and we can copy the modifiers from the selected to active object. If we select the door and window cutter object, press GZ and drag down. The objects will disappear. Some edges become visible as we drag down, but edges don't render, so they will be fine. Here in my file, some artifacts remain, so I'll select these and tab into edit mode. Press Z and switch to wireframe shading also so we can see these. I need to zoom right in here. These are extra vertices created by the ArchiMesh add-on when creating the door. I need to select all these extra single unconnected vertices. Press X and delete. You may come across this yourself, so make sure and delete them. So now tab back and switch back to Material Preview. Let's put the cutter object back to 0 so we can see how many more we need. We'll need 1 for the roof, 2 for the floors, 1 for the external wall and 1 for the stairs. So that's 5 more. Let's select one and press Shift plus D and right click. Press F2 and rename this roof underscore cutter. We can tab into edit mode and come into a top view. Let's select it all and move center of the roof first. Then scale down on the Y-axis and bring it closer to the size. But make sure it's still larger. Scale on the X also. Let's come into a front view now. We can drag this up and center on the roof. Now scale this down along the Z-axis and just cover the roof. Adjust its position if necessary. We can tab back now. Let's press Shift plus D and right click. Press F2 and rename this one FF underscore floor underscore cutter. We can tab into edit mode. Select it all and drag down and cover the first floors. Make sure they are covering these. Shift plus D again and drag down and cover the bottom floor. Make sure it's covering the base also. Press P and we can separate this by selection. Tab back and select it. Press F2 and rename this GF underscore floor underscore cutter. Next up are the outer walls. Let's select the wall cutter. Press Shift plus D and right click. Press F2 and rename outer underscore wall underscore cutter. Let's come into a front view now and tab into edit mode. Select it all. We can drag this to about center of the wall. Now S, Shift Z to scale along the X and Y axes and cover the walls. Reposition and scale so it just covers the outer wall. We can stay in edit mode for the stairs, so press Shift plus D and right click. Press Z and switch to wireframe shading. Press S, Shift plus Z and scale this right down. We may have to rotate around to see the stairs. Press G, Shift Z to eliminate the Z axis when moving and keep the bottom in position just below the floor. Now scale and position this cutter around the stairs. With that done, let's press P and separate selection. We can tab back now. Select this and press F2 and rename this stairs_cutter. Then for each of these objects, we can add a Boolean modifier and use the picker to add the cutter as the object. Set the solver to fast. I can quickly work around and add a Boolean modifier to the remaining objects. This ground floor cutter object needs to be extended over the front step, so I can drag these vertices forward in edit mode. Once these are all done, the only remaining objects visible should be the balcony railings. In this video, we set up the camera with a follow path and track 2 constraint. Let's get started. When animating, it's always useful to do it from the camera view. After all, this is what the viewer will see while watching the animation. So it's helpful to see it from that perspective. In the outliner, let's shift select all the cutter objects. Press G, Z and drag these up to reveal all the components of the building. Then from the add menu, we can add a camera to the scene. To help control the camera, let's switch into the animation tab and use that screen layout. In the left viewport, press numpad 0 and enter camera view. In the right side, let's press the / key for a moment and take a look at the camera. The triangle here indicates the top of the camera and also the front. The tip here is the viewing point, and anything to the front side of this point will be seen by the camera. This is also the origin of the camera and the rotation point. You'll notice this triangle is filled in, meaning this is the active camera. The active camera is the one used when rendering. If there are multiple cameras in the scene, you can switch between them and render at different frames. If I add a second camera for a moment, notice how the triangle is not filled, whereas the original camera has still the fill. If we switch to the Scene Properties tab, we can switch between the scene cameras here. This doesn't make the camera active, but just switches into that camera view, and you'll notice that in the left viewport here. To make this camera active, press Ctrl plus numpad 0. Notice how the camera's triangle fills in and it's now the active camera. We can press X and delete this camera. We can select the original camera again. In the left viewport, press Ctrl plus numpad 0 to make it active again. Let's come into a top view in the right side. Press G and drag the camera back from center. If we try to rotate in camera view, we exit the camera view. Press numpad 0 to return here. If we press N and open the View tab, here we can check on Lock Camera to View. Now, if we use the navigation controls like Zoom, Pan and Rotate, we can do so controlling the camera. So let's position the camera back a little and get a good distance and frame up our model. In this viewport, the overlays are switched off, meaning less clutter in the viewport, including the cutter objects. Use the Overlays button to toggle on and off the visibility if needed. I find leaving them off makes it easier to spot any issues with the animation. If you are happy with the camera position, then press N and uncheck the lock so you don't accidentally move the camera from position. That way you can zoom in and make the camera view larger. Let's return to Global View now. Let's come into a top view. Press Shift and right click and place the 3D cursor about center. Then from the Add menu in Curve we can add a circle. Then tab into Edit mode. Press S and scale this out to approximately the camera's origin. Zoom in here and make sure that lines up accurately. Press numpad 5 for an orthographic so we can see this correctly. Now get that aligned correctly. We can zoom back out now and also tab back to object mode. Press F2 and rename this cam_path. Let's actually drag this object and the camera. Press M and create a new collection. Rename this camera. In the outliner, we can press the period key to jump to these objects. Select the camera collection so the next object gets added inside. We need a camera target object, so from the Add menu in Empty, we can choose a cube. Press F2 and rename this cam_target. Next, we can select the camera and open the Constraints tab. Then from here, we can add a Follow Path constraint. Now, before setting the constraint, press N and open the Item tab. We can clear out the transforms, so press Alt+G and clear Location, then Alt+R and clear the rotation. That places the camera back at center. Now in the target, we can choose the cam path object to follow. That snaps the camera onto the path. Now we need to track the empty we added. So we can add a track to constraint. Then in the target, search cam target and add this here. This setup lets you control the camera in a few different ways. You can scale the circle and move the camera in or out. You can also change the pitch of the camera by moving the circle up or down. If you select the cam target and press G, the camera will follow this. This allows you point the camera in any direction. Scale this up to help identify it and select it more easily. Select this in the outliner. In the Object Properties tab, we can check on Show Name, so there is no confusion selecting this object. Finally, we can select the camera. In the object constraint, you can control the position of the camera on the circle by using the offset setting on the Follow Path constraint. This should give us enough control to animate the camera and capture the animation. In this video, we set up an empty object to control the position of the ground planes. Let's get started. To begin, we can select the tabletop and the plan objects. Press H and hide these for a moment. We can press Shift+S and put the cursor back to World Origin. Press Shift+A and from the Add menu in Empty, let's add a plane axis. We can press S, Input 5 and make this large enough to see. Now we can select the grass. Shift select the tiles and Shift select the stones. Then come around and Shift select the empty. Press Ctrl+P and set parent to and keep transform. That way we can select the empty and press G. All three objects move along. We'll use this to control their position later in the animation. Let's press F2 and rename this empty_ground_control. Press Alt+H and unhide those two objects. In this video, we add keyframes under roll control. Let's get started. We are now ready to start animating. We'll begin with the plan rolling open, and that happens over the course of 1 to 1.5 seconds. If we come to the Output Properties tab, make sure the frame rate is set to 24 frames per second. In the dope sheet below, the numbers here are the frame numbers, so every 24 frames is equal to 1 second. In the View menu, I like to check on Show Seconds. The frame numbers get replaced with the time in seconds. You'll notice the label on the scrubber displays seconds and frames. So if I drag this across to 0, 1 plus 18, here this reads 1 second plus 18 frames. In the outliner, let's make some space and expand the cutter object collection. Let's shift select all these objects. In the scene, press Alt plus G to clear out the location transform and place these back on the ground. That way we have a better view of the plan rolling open. Let's select the roll control object. We'll need to make sure the scrubber is back at frame 1. Click this Jump to Endpoint button to place that back. Press GX and drag this across to its start position and when it's rolled up. About here where it's fully rolled up looks good. To set a keyframe, we can press I. This opens the keyframe menu and we can choose a location keyframe. That keyframe will store the object's location at frame 1. This plan will roll open over 1.5 seconds. So we can move the scrubber to 1.5 seconds or 1 plus 14 on the timeline. Then press GX and drag the control object until the plan is flat. Make sure it fully lays flat on the tabletop. Then we can press I and add a second keyframe for its position at 1.5 seconds. So now if we click the scrubber to the start and press the spacebar to play, the plan will roll open. Use the button below here to restart the animation over and over again to get a sense of the timing. The shortcut is the Shift plus the left arrow key. The frame rate indicator here displays how close to the full 24 frames the animation is playing back. You rarely get this full 24 as the computer has to work hard to play back animation. We'll look at exporting a play blast later so you can get a better idea of the timing. You'll notice here the roll starts slow at the beginning, speeds up and slows at the end, and that's due to the interpolation type. By default, when you set keyframes in Blender, they use Bezier, and we can visually see that if we open the graph editor. In the View menu, we can toggle Graph Editor. I can press Ctrl plus space to make this full screen. Here we can see the Bezier shape easing in and out. We can change this to linear to get straight line interpolation as the plan opens. So press A to select all the keyframes. Press P to open the menu and in here we can choose linear. That updates, so let's press Ctrl plus space again and return. We can also press Ctrl plus tab to toggle back to the dope sheet. The green line gives us a visual of the interpolation type. We can play this again and take a look at the changes we made. That looks very good with no speed up or slow down. If you'd like to change the speed the plan rolls open, you can by adjusting the position of the keyframes. So clicking the top channel selects all channels beneath. Then click and drag back to reduce the amount of time, or drag forward to increase the time it takes to open. I can right click to cancel. It's easy to change the timing by adjusting the keyframe positions. In this video, we set up the camera. Let's get started. We can begin with the scrubber at 1 plus 14. We can set up the camera start position, so use the cam path and cam target objects to move the camera into the first position. This might take a while as I want to frame the entire plan and fill the camera view with the table. I want a certain angle on the camera also, so that will involve moving the cam path object and adjusting its scale. Adjusting the scale moves the camera in and out. I can quickly adjust all these objects and get the camera into position. Once you're happy, we can make this left side viewport full screen by pressing Ctrl plus space. Then press space and play the animation. This will be the position of the camera until the walls start appearing, and at that stage the camera will move in closer and start to rotate. That looks like a good starting position, so let's click back to previous and add some keyframes to store the camera location. We have three objects: the camera offset value, the cam path, and the cam target that we need to record. So select the cam path object first. Drag the scrubber to 1+14 and where we finished the roll control animation. Because this will be the start position for the path object, let's first press Ctrl plus A and apply all transforms here. That way, if this moves from position, we can zero it out. If you find a better start position later, just apply the location again. So press I, and this time we can add a location and scale keyframe here, as we need both location and scale values stored. Next, we can select the cam target object. Press I and add a location keyframe here also. Finally, we can select the camera. In the Object Constraints tab, we can click this Animate Property button to store this offset value at this frame. In this video, we start revealing the walls and ground floor. Let's get started. Now we can move the camera in close to start capturing the walls forming upwards. So select the cam path object. We can drag the scrubber onto 4 seconds and where we want this movement complete. Now press S and scale down the cam path object so the camera starts to frame the wall on the drawing. We'll adjust the rotation next. Press I and add a location and scale keyframe here. Select the camera next. In the Follow Path offset, rotate the camera around and square it up. We can click and store this value. We can also move the camera up, so select the cam target object. Press GZ and drag this up and finish framing the camera view. Press I and store this location. I need to select the camera again and adjust the offset value to match the lines of the drawing. Now update that keyframe. So now if we start at the beginning and play this back, the plan rolls open. Then once open, the camera moves in close and ready for the walls to appear. Let's zoom in here and select the wall cutter object. The scrubber can be moved back to 4 seconds and where the movement will start from. Press I and add a location keyframe here. Then we can drag the scrubber forward to 7 seconds. Now press GZ and drag this up until the top of the ground floor walls are up. Don't go too high here, as we don't want the very top floor revealed at this stage. Instead, we'll use the floor cutter to reveal this section beneath the individual floors. So press I and store the location value here. Next, we can select the ground floor floor cutter. Drag the scrubber back to 4 seconds in the dope sheet. Press I and add a location keyframe here. Now we can move the scrubber onto 8 seconds. Then press GX and drag this in the -X direction and reveal the floor. Zoom in and make sure it's fully revealed here. We'll move the camera into position next to capture this movement across. Press I and add a location keyframe here. Next, we need to move the camera around. Our last keyframe is at 4 seconds, and from here the camera will rotate around to 14 seconds, doing a full 360 resolution. We can click and drag in the end field here and move the end frame out past 14 seconds. So let's move the scrubber out to 14 seconds. Then in the Constraints tab, use the offset to rotate the camera right around the house and back to about where it started. Then add a keyframe to store this value. If we drag the scrubber back along here, we should get a full resolution. The camera is probably a little close to the model in parts, so we can adjust its position as it rotates. First, let's select the cam path object. Click the Jump to Keyframe button to land on the last keyframe for this object. We will want the location and scale value for this object at frame 14, so click the top channel to select them all. Press Ctrl+C and copy. Then move the scrubber to frame 14. Press Ctrl+V and paste these here. We can update this value later for a better ending position, but this is a good starting point. Let's move the scrubber along here and find where the camera is closest to the model. About here, around 10 seconds. Press S, Shift Z and exclude the Z axis from scale. Scale and move the camera straight out from this position. Then press I and add a location scale keyframe. So now if we drag forward, the camera will rotate around, keeping the building in frame until it comes back to rest at frame 14. In this video, we continue to update the camera position. Let's get started. We have this end keyframe where the camera stops, and we can update this now so it better captures the roof and railings. So let's select the cam path object first. We can move the scrubber onto 14 seconds and the last keyframe for this object. Let's press S, Shift Z and scale this out on the X and Y axes. Then G, Z and drag down to get a better view of the objects. Press I and add a location scale keyframe. That's the first of two camera positions. As the grass rises and the external walls reveal, we'll move the camera down further so the tabletop is no longer visible. Now select the camera. In the Constraints tab, we can adjust the offset value and square up the camera view a little bit. I find aligning the lines of the texture with the outline of the camera one way to get it fairly straight. Update that keyframe once you're happy. So now we can drag back and forth and take a look as the camera moves around and rests in the new position. That looks better and it captures the railings moving into position. Now we need the camera's final position, so let's move the scrubber onto 15 seconds. Select the cam path object. Press G, Z and drag this down and get it roughly in position. Press I and add a location scale keyframe. This position will be updated if necessary when all the other objects have keyframes. Let's move the scrubber to 13 seconds. We can select the roll control object. Then shift select the plan. This will move away over 2 seconds. So first press I and store the location keyframe. Then we can move the scrubber onto 15 seconds. Press GX and drag the plan away to the left side and out of view. Then press I and store the new location. Over this time, the external walls will also reveal. So let's move back to 14 seconds. Select the external wall cutter. Press I and add a location keyframe. Then move the scrubber to 15 seconds. Now we can move the cutter back along the Y axis, so press G, Y and drag this back to reveal the wall. If you happen to get a glitchy result here, I can just leave this about halfway for the moment. Select the wall. In the Modifiers tab, change the solver to exact and fix any issues. Now drag this back and show the entire wall. Press I and add a location keyframe. So now, as the camera moves to the final position, everything gets into position very quickly. In this video, we reveal the roof, railings and windows. Let's get started. Now we can move on and reveal the roof and animate the balcony railings. So let's select the roof cutter object. Then move the scrubber to 10 seconds. Over the course of 4 seconds, the roof will reveal, so press I and add a location keyframe here. Now move the scrubber to 14 seconds. Then in the scene, press GX and drag this across and reveal the roof. Make sure the roof is fully revealed at 14 seconds. Zoom in and make sure it's not too far past the roof either. Press I and add a location keyframe here. At the same time the roof is being revealed, we'll want the railings to start arriving and landing into position. So at 13 seconds, the railings will be in position. Let's switch to wireframe shading so we can see the empty object we set up to control the railings. These are at world origin. Drag select the 3 objects. If we press G, all 3 will come along. Right click to cancel. With the scrubber at 13, we can press I and insert a location rotation keyframe for these. Let's move the scrubber back to 10 seconds. Then if we zoom out in the scene, we can see this a little clearer. Press GZ and drag these straight up and out of the camera view. If we press the period key in the outliner, you'll bring these objects into view. That way we can select them individually. In the pivot menu, make sure this is set to medium point. Then press RZ and rotate each around so all 3 have a different orientation. We can also move the 2 outside railings away along the Y-axis. For the center one, let's move this along the X, so this also needs to travel back along the X-axis to get into position. Shift select all 3 now. Press I and add a location rotation keyframe here. We can press Z and switch to material preview in the scene. Then press the spacebar and give this a playback. It's playing back very slowly, but all 3 are moving back into position as the roof completes. We can also check if the railings are visible in another part of the shot by scrubbing back and forward and making sure they are not visible at any stage. That looks good. Let's reveal the doors and windows now. This will be over 2 stages and match the ground floor walls and first floor walls. So let's move the scrubber to 4 seconds. Select the door win cutter object. Press I and add a location keyframe here. We can move the scrubber on to 7 seconds. Then press GZ and snap up to the top of the wall cutter. That way they move at the same rate. Press I and add a location keyframe. We can move the scrubber onto 8 seconds now. Press I and store this location keyframe. Now move the scrubber onto 11 seconds. Press GZ and snap to the top of the wall cutter. Press I and add a location keyframe here. So now if we drag back and forth, the windows rise up at the same rate as the walls. Feel free to change how these are animated. We'll need to improve the camera view towards the end, but we'll do that in the next video. In this video, we reveal the first floors and complete the walls. Let's get started. For the next part, we'll have the first floor reveal. But at the moment, the base of the first floor is part of the walls, and we need these part of the floors. So we can separate first, then join to the floors. So let's press numpad 1 for a front view. Press Z and switch to wireframe shading. Now tab into edit mode. We can press Ctrl plus space and make this full screen. Now drag across the internal vertices between the ground and first floors. Press P and we can separate selection. Let's tab back now. If we select the wall cutter, press GZ and drag this up for the moment. That way we can select the object we just separated. Now let's click back to previous. In the modifiers tab, let's click and remove the modifier. We can join this next. Let's switch back to material preview. We need to select this first floor cutter. Press G and drag this away along the X-axis for a moment. That way we can select the object we separated. Shift select the floor. Press Ctrl plus J and join into one. We also need to update the keyframes of the wall cutter, otherwise there will be a gap. So with it selected, let's move the scrubber back to 7 seconds and the last keyframe. In the scene we can press G, Z and snap to the bottom of the floor object. Now press I and update the location keyframe. Now we are ready to add keyframes to the first floor cutter object. So select this. In the X location, input 0 and put that back at the start position. Make sure the scrubber is back at 6 seconds and where this floor will begin to reveal. Press I and add a location keyframe. Then we can move the scrubber onto 10 seconds. This will match the speed of the ground floors. We can zoom over to the end of the ground floor cutter. That way we can press G, X and snap this over and match that position. Now press I and add a location keyframe. Now we can finish the walls up to their full height. So select the wall cutter object. Move the scrubber to 8 seconds. Press I and add a location keyframe here. Next, move the scrubber to 11 seconds. Then press G, Z and drag this up until the walls are fully revealed. Now press I and add a location keyframe. Then drag the scrubber back and forth and make sure everything looks as expected. We'll render a play blast or a low resolution test once everything is set up and make timing and position adjustments at that stage. But keep note of the things you'd like to change as we set this up. In this video, we animate the trees. Let's get started. Now we can start adding the trees to the scene. We'll do that two ways. The first will be similar to the balcony railings and move down onto the ground. The second will be more like growing trees where we'll scale them from 0 to a full size. Let's start with moving them into position. In the outliner, we can press the numpad minus key and close these collections. Find the tree collection and switch it back on. Select the tree collection. Then in the scene, press Ctrl+H, and from here we can isolate this collection. Let's press Shift+S and put the cursor to world origin. Press Shift+A and we can add an empty, plain axis. Let's press F2 and rename this empty_tree. Drag select everything now. The empty is still the active object and the lighter color. Press Ctrl+P and we can set parent to and keep transforms. So now if we select the empty and move it, the tree follows along. We can right click to cancel. In the outliner, we can switch back on the visibility of the animation, cutter and camera collections. In the scene, make sure the scrubber is close to the end of the animation so the external wall is visible. Then we can come into a top view. Press G and drag the tree to the back wall and position here. We can have these landing around 13 seconds so the camera will capture them fully. Maybe press S and scale this down a little. Let's move the scrubber to 13 seconds. Then press I and we can add a location, rotation and scale keyframe. Move the scrubber back to 11 seconds. Then press G, Z and drag up away from camera view. Press I and add a location, rotation, scale keyframe. So now, dragging this along, the trees come into view and come to rest at 13 seconds. Now I'll show you how to make a copy and update the keyframes. It's really similar to what we have been doing. So move the scrubber to 13 seconds. Press the period key in the outliner and jump to the empty. Select this and right click and select hierarchy. This selects all the child objects. Then in the scene, press Shift+D, X and drag this across here. Now press I and update the new location, rotation and scale values. Really the location. Now if we move the scrubber back to 11 seconds, both trees will be in the same location. So press GX and drag this away. We can also press RZ and rotate this around. Press I and update the keyframes now. So between videos, try add a few more trees. Even rotate and scale them on 13 seconds so they look a little bit different. Now we can have a tree grow from a scale of 0 up to whatever size we want. So let's move the scrubber onto 16 seconds. In the outliner, we can select the empty and right-click and select hierarchy. Press Shift+D, Shift-Z and drag this across to the right side of the house and position here. Probably best remove the keyframes, so in the dope sheet, press X and delete keyframes. Then select just the empty. Press I and add a location rotation scale keyframe. Then move the scrubber back to 14 seconds. Press S, input 0 and enter. Press I and add a location rotation scale keyframe here. Now if we move the scrubber back and forth, the tree scales from 0 to full size. It's probably a little large and the branches are coming through the walls, so move the scrubber onto 16 seconds. Press S and scale down so it's not too large. Then press I and update the keyframes. I think the two back trees are coming in too early, so select each of the empties. Then with the keyframes highlighted, press G and drag these further along and have them arrive later, maybe 14 seconds. Repeat that for the second one, but don't move this as far forward and keep the timing slightly offset. In this video, we animate the stairs and the grass moving into position. Let's get started. We can drag back towards the beginning of the animation and to where best to add the stairs. We have a Boolean object set up on this, or you can do something similar as the balcony railings. I think I'll subtract this with the cutter object. So move the scrubber to 4 seconds. Select the cutter and press I and add a location keyframe here. Then move the scrubber onto 6 seconds. Then press GZ and drag this up and reveal the stairs. Press I and add a location keyframe for 6 seconds. So now if we drag back and forth, the stairs is captured well in this camera view. Next, we can move the grass, tiles and rocks into position, so select the grass. In the modifiers tab, we can switch on the geometry nodes here. These were reduced in number earlier, so it's not too hard on the viewport. We can move the scrubber to 15 seconds and where these objects will come to rest. Press I and add a location keyframe here. Now let's move the scrubber back to 13 seconds. Let's press Z and switch to wireframe shading so we can see these objects. We can also come into a top view. Press GX and drag away off the tabletop, as this will be visible early in the animation. Press I and store the location. Let's drag the scrubber to about the 15-second mark. We can see from camera view here there is a gap between the plan and the ground, so let's close that up. Zoom into the edge of the plan. Press GX and drag the ground up close on the plan at this frame. Press I and add a location keyframe here. Check the scrubber as you may have to move the ground again as there will be more gaps. I can quickly check this and correct any gaps. Add a few more keyframes along here to remove that gap. This can be checked in the test render for any timing or gap issues. In this video, we begin adding assets from our asset library. Let's get started. Now we want to add furniture objects at different locations of the animation. For this example, we can use the Cube Diorama asset pack from the blender.org website. I covered setting this up in the asset browser lecture, so watch that if you haven't those assets linked in your preferences. I'm going to make some space here on the bottom right. drag up and split the Properties editor in two. Then we can switch this to an Asset Browser editor. Then from the drop-down, select the Cube Diorama library. I'll demonstrate adding a desk to the scene, so I can find this in the list here. Now drag this into the scene. This will land in at 5 seconds, so move the scrubber to 5 seconds. We can also zero out the Z location field and sit this on the ground. Let's come into a top view. Drag this over and position inside the building. Press I and add a location keyframe here. Now we can come into a front view. Move the scrubber back to 3 seconds. Then in the scene, press GZ and drag this up and out of view. Press I and add a keyframe here. So now, if we drag along, the table lands into the building as the floor passes underneath. This will look much better with many different models landing into the house, and there are many available online for download. I'm sure by now you have an asset library. If not, I'd recommend starting one. If you don't have any more models, why not add more from the Cube Diorama file? I'm going to add a few more from my library, and I can do that before the next video. In this video, we render a viewport animation. Let's get started. At this stage, we have keyframes added to all the objects, but it's very hard to tell if the timings are okay. That's where viewport render animation will help. This will render exactly how the scene looks now, and each frame renders almost instantly, so it's very fast. We do need to set up how we want the animation to render, so open the Render Properties tab. Here we can change the file format from the default PNG to a video format FFmpeg. Then in the encoding area, change the container to MPEG-4. The default codecs will be fine here. Finally, in the output section, we need to choose a location. The default is the temp folder, but choose a location in your project folder. I can create and use this folder. Quickly give it a name. Usually you'll create tons of preview renders, so sequencing them to look back at the changes can be helpful. We can accept this location. In the right side, let's come into camera view. That way it will render this view. Make sure the frame range is close to the last keyframe, otherwise it will render unnecessary frames. I have this closed up about 16 seconds. Back in the view menu, we can come down and choose viewport render animation. This will take a few minutes, so I'll speed it up. With the rendering complete, I'll double click and play the video. That will play back at the full 24 frames per second and give you a good idea of the timing. So it's good to spend some time and study your own. Also, look out for any noticeable issues such as objects that shouldn't be visible or any artifacts. One issue you may encounter is a material showing as the boolean cuts through. I can close this window. If we select the wall and open the material tab, the first material listed will appear as the boolean cuts through. Select the color or material you'd like to be visible and use the arrow button to move first in the list. We can continue creating the animation in the next video. In this video, we set up Eevee. Let's get started. Hopefully, you've reviewed your viewport render and made the necessary changes, fixed any timing issues, and removed any artifacts from the render. I'd recommend rendering another viewport render after any changes to make sure everything is as expected. We're moving on to a full render, so it's important to have everything fixed at this stage. These renders take a long time, and you'll save yourself considerable time and heartbreak having all the issues ironed out before proceeding. Let's begin in the Render Properties tab. Blender has two render engines for final render, Eevee and Cycles. Eevee is Blender's real-time render engine, and Cycles is a physically based render engine. Eevee will give good results quickly. Cycles will give a more realistic result, but take more time to render each frame. If you plan on using Cycles for final render, then using Eevee is useful for testing. Let's look at Eevee first. The default sampling values work well, so no need to change these here. Settings such as ambient occlusion and screen space reflections will cost more in terms of time, but it won't be very noticeable as Eevee is very fast. Let's move down the bottom to color management. Here, the default uses AGX, but choose a preset to help improve the colors. Median high contrast, for example. Let's move on to the output tab. The image resolution is 1920 by 1080 and more than what we need. These will produce HD images but take a great deal of time. Consider reducing the resolution to HD 1280 by 720. This will greatly reduce render time. Just update the values here if your computer takes too long per image. Next we have the end frame. My last keyframe is about 16 seconds, so the end frame can be set to 408 or 17 seconds. So update that end field value here. The end frame can be extended further in the video editor after rendering. Next we have the format. Rather than render a video straight from Blender, we can change this to PNG images. Images are easier work, especially if you have artifacts when rendering. You can simply render one particular frame again and fix any issues. Next, we can check the output folder. We can create a new folder in the project folder. Give the folder a name. This can be called House Animation. Now we can accept this. We can move the scrubber to about 13 seconds. Then press F12 and give this a quick test render. That will open a separate render window on screen and render the image, and I can speed this up. The time to complete the render will be displayed up top here. This is quite fast as it stands, but what will help is disabling the geometry nodes within the frame range. They will not be visible. This will result in rendering out the animation in two parts. The ground only starts to move across at the 13-second mark, so we only need to have that visible from then on. So let's set up the frame range to render the first part of this animation. Move the scrubber to 13 seconds and the first keyframe for the ground control. Then press the left arrow button to move back one frame to 311. This will be our end frame for the first part of the animation. So in the end frame, let's input 311. The grass will only be needed rendered from frame 312 to 17 seconds. So we will render that section when it's switched on later. So select the grass object. In the outliner, press the period key to bring this into view. We can switch off the disable in render icon here. In the modifiers tab, we can disable the geometry nodes modifier. Now press F12 again and give this another render. While this is only a small increase, it will be more noticeable when rendering with cycles. So it makes sense to render this animation in two stages. The first stage will be from frame 1 to 311, then the second stage from 312 to 408. The HDRI is rendering as the background, and that will be fine, so you can swap out the HDRI with another image if necessary. That's Eevee set up, and you are ready to come to the render menu and render animation. In the next video, we look at setting up cycles, and that's what I'll be using. We'll also set up the second stage of the frame range in the next video, so be sure to watch that. In this video, we set up and render with cycles. Let's get started. Next, we have the Cycles render engine, so in the Render Properties tab, switch to Render Engine here. Recent improvements to Cycles has considerably reduced render times and narrowed the gap between the two render engines. Cycles is a physically based renderer and will give you more realistic results. In the sampling section, we can reduce the max samples to 80. Blender have a denoising feature we can use to reduce the noise, so no real need to use a very high value. Increasing this will increase render times, and you can always increase it if you have the time to render. Let's press F12 and give this a quick render. This will take a lot longer than Eevee, but the render will be more accurate. I can speed this up. Using low samples can cause the image to be grainy in places. You can increase the samples to improve the render quality, but this increases render times. We can use the denoising feature, so switch to the Layers tab. In here, make sure denoising data is checked on. This will allow us denoise the image in the compositor once rendered. So let's switch into the compositor. Check on Use Nodes up top here. Let's move the Render Layers node back a little. Press Shift+A and from Filters we can find and add the Denoise node. Drop that over the line and connect this up to the noisy image output. Now press F12 again and give this another render. I can speed this up. Denoising will clean up the image and we can see it has removed a great deal of noise. This node setup can be left in place when rendering the animation. Let's switch back to the Animation tab. Once you are happy with your test renders and there are no obvious issues, pick your render engine. I'm going to use Cycles, but use Eevee if that's what you want. I'm going to render the first frame section first. Then in the next video we can set up the second frame range and render the remaining, including the Particles and Geometry nodes modifier. One last thing is to select the plan. In the Modifiers tab, apply the Subdivision Surface modifier so the edges of the plan are smooth in the final animation. So with that, let's come to the Render menu and render animation. In this video, we render the second section of frames, including the grass. Let's get started. Hopefully, you have the first section rendered successfully. You should have a list of images in your output folder and we'll look at combining these in the next video. Right now, we need to render the second section of animation. In the end frame, let's input 408. This will be the full length at 17 seconds. In the start frame, we can input 312 here. Now the important part. In the outliner, let's find and click to include the grass object in render. Do that for the stone particle objects if you disabled that. Make sure the grass modifier is switched on in the Modifiers tab. Then open the Geometry Nodes tab. We can increase the density value to 500 or more depending on how you want this to look. This will slow the viewport. You can try lowering value if you find your computer too sluggish. I'm going to reduce the Z-scale to 0.1 as the particles are too high. Now we can switch back to the Animation tab. In the outliner, we can disable the grass from view. This will help speed up your viewport and the grass will render. That way, if you need to test render the changes we made, the viewport will be responsive. We are now ready to render the remaining frames, so from the Render menu, let's render animation. In the next video, we can take all the images and combine them in the video editor. In this video, we combine the images into the final video file. Let's get started. Now we are finished with this file, so make sure and save. Then we can come to File, New, and start a new video editing file. This is the video editor in Blender. On the bottom, we have the sequencer where you can add the media. Then the sequencer preview above this. We can add our rendered images. They get rendered in sequence based on the frame number, so from the Add menu, we can choose Image Sequence. Navigate to where you saved the images. Press A to select them all, and now add Image Strip. This strip extends beyond the end frame, so we can press the page up to jump to the end of the strip. Now press Ctrl+End and close this up. We can press GY and just drag this strip to about channel 3. Press the spacebar and play through and take a look. Check for any issues with the animation, any artifacts, bad timing or errors in general. If you come across any, you can remove any frame and re-render. Plus, by playing this right through saves to cache, so the next time you'll get the full 24 frame playback. So for example, if you see an issue with one of the frames here, frame 96 for example, the scrubber or playhead displays the image to the right side. So if you wanted to remove the image on screen, select the strip, press K to make a cut. Press the right arrow key to step forward one frame. Press K to make another cut. This image is now free, so select it and press X and delete. So if we press the left arrow key, we are missing frame 96. Then you can open back up the animation file and fix the issue, then re-render that frame. save that image and add it back in here. We can press Ctrl+Z to undo before we cut that strip. Let's add an intro and outro, then render our video. Select it all. Press GX and drag the strip out to 2 seconds or 48 frames. Press Shift and the left arrow key and move the scrubber back to the beginning. Press Alt+A to deselect. Press Shift+A and from the Add menu we can add a color. Press GY and just drag this up. In the sidebar you can change the color, but black will be fine. We can also add a text object. Press Shift plus the left arrow just to make sure the scrubber is back at frame 1. Press Shift+A and from the Add menu add a text. We can move this up above so it's not hidden by the color. On the sidebar we can change the font type here. This will open to the fonts folder on your computer. If not, just navigate to that folder. It's C, Windows and Font on mine. You can change the view type to thumbnail to get a preview if it's not already set. This font here will do, so I can add this in. The panel here lets you change the size, color, position and many other properties. Let's update the text to House Animation. Increase the size to about 100. We can also increase the length of the text to 2 seconds. So grab the handle on the right, press GX and drag out to about 2 seconds and left click. Zoom in here and we can actually move it to the end of the image strip. Press Shift+S and snap to the scrubber. Now move the scrubber to 1 second. Over in the text properties, let's click and add a keyframe to the opacity value of 1. Press the page up a couple of times and come to the end of the strip. Now reduce the opacity to 0. Then add a keyframe. Click the scrubber back to the beginning. Reduce the opacity value to 0 and add a keyframe here. Next, we can add a cross between the color and the image strip. Select the color strip. Press Shift and select the image strip. Press Shift+A and from transition we can add a cross. Move this back to the start and give it a play. That looks fine, so let's move the scrubber past the end. Then press page down to snap to the end of the strip. Drag this forward 1 second. Press Shift+A and add a color strip. Select the image strip, then the color. Press Shift+A and add a cross. Press page up and snap to the end. Press Ctrl+End and close up the timeline. Press the spacebar and give this a playback. You can add more text to the end, but this will do for the finished video. Now we are ready to render the final video. So in the Properties editor, in Output, we can change the format to be FFmpeg video. In the encoding drop-down, we can set the container type. I usually change this to MPEG-4, as it's compatible with most platforms you might share on. The video codec can be left as default. If you are adding epic sound to the video, then select an audio codec from the list. AAC or MP3 works well. Finally, we need to select the output folder. This will be in my project folder, here in Final Video Output. Now accept. So now we are ready to render the finished video. So let's press Ctrl+F12 and render animation. This will render very quickly and I can speed it up. I can open this off screen. This plays in my default video player VLC. It's free and very reliable. That's it complete, and hopefully you've enjoyed the course, and I look forward to seeing your final results and reading your feedback.